Nd:YAG laser. So this is a generally, if we open that box, we will see Nd:YAG laser will be like this inside, but we will see how it will be look outside. Basically, if we consider any laser, it have a always active media, pumping media is there, and a cavity. One resonating cavity is required. These are the three parts for any type of the laser. So when come to Nd:YAG laser, basically it is a solid state laser, and this cavity is this whatever we take a Nd:YAG rod. One side it's a completely polished, and other side partially polished. That will work as a cavity. And pumping system, we will use a krypton flash lamp, which provides the energy. And when we see the cross section, the design will be like this, like a elliptical. Two foci will be there. In one foci, Nd:YAG rod will be there. Other foci we use krypton flash lamp, so that most of the energy will be utilized here, right? So this is just a outline. We will see one by one how it will work. So basically, that Nd:YAG laser is a combination of ND and AD. YAG stands for Yttrium Aluminium Garnet, Y2Al5O12. So basically, this is a colorless isotropic crystal, yttrium aluminium garnet. Once we dope with the neodymium 3 plus, that color slightly changes. It will convert it into light blue color, that yttrium rod. Then average power it will produce is 1 kilowatt. It's a high power laser. It basically, and it will produce. Then how it will be constructed? So basically, the construction of the laser will be, we have Nd:YAG crystal cut in the form of cylindrical rod from 5 to 10 centimeters, hardly, and a diameter 6 to 9 very small in size. And this Nd:YAG rod is placed inside one of the foci of elliptical reflector cavity. So that is what we have previously told. It's a elliptical cavity. This is a one foci, this is another foci. One place we will keep lamp, another place we will keep Nd:YAG crystal. So at the other focus, the krypton flash tube, which is connected to the power supply. So the lamp we will use in order to pump the atoms to excited state. This is what we are speaking. Especially this is the cross section, and this krypton flash lamp is connected with a power supply and resistor, and parallel to it a capacitor is connected. Right now, if we open it, it will look like this, and just we will see a video how it will work. So this is the Nd:YAG crystals and a foci place. Lamp will be there, and one side it's a completely polished, other side it partially polished. So when light glows, what happens? It's a pump the energy. That energy will be absorbed by this rod, Nd:YAG rod. So then lasing action will start inside it, and the energy is less, so it will continuously reflect in inside until it will get sufficient energy. So once it get sufficient energy, it will come out as shown in the figure, and that will be guided, right? So this is the process continuously happen in Nd:YAG laser. Now, so working is very simple. Whatever we saw now, that's the same thing. So what happens? Optical pumping, that's a lamp is used, and even though lamp is producing so much energy, small portion of it is used for pumping purpose, and most of the energy will be gone out as a heat. It will heat up the apparatus. So it's a cooling mechanism is required for this Nd:YAG laser continuously. So cooling system we always keep there. Then once we supply the external energy through optical pumping, neodymium ions absorb the radiation. So even though we have AG and ND, ND only matters for us. It's a do all the required things like a stimulated emission. So once it absorbs, it will get go to respective excited states. So once they go to excited state, they may not stay there for longer time. So then they will come to the metastable states. Like here we can see E0, E1, E3, E2, E3, E4, right? So here go to excited state. Whenever they come down, they will form a metastable state. So from metastable state to next state, if it is moving, it will release the laser 1064 micron or 1064 nanometers. And from E1 to downside, it's a non-radiative decay. It's only produce the heat, no light here and here. Now it will produce actually this one. Then we will use other optical components in order to get the different wavelengths. Half of this we will get three times fourth part, like that we will get different wavelengths we will get from this Nd:YAG laser. Once we get the different types of the lasers, next thing is what is the advantage compared to other lasers. Basically, it's a high energy output lasers. So for cutting, welding, and drilling purpose, we can use. But when come to the helium neon laser is a low power laser, and this is the high power laser. Then we can tune for pulsed laser or continuous laser as well, and good beam quality, and it can be configured as pulsed laser or continuous wave laser, and reliability, long lifetime will be there. These are the few advantages, but the other side of the coin is the cost is very high to maintain, and operation requires expertise skills, and it will create the heat. So we always required pumping of the coolants. Then size and weight is little high. We cannot integrate it, or we cannot install everywhere like a helium neon laser. It's a little expensive as well, and it's a single wavelength. At a time we can use only one wavelength, which limits their versatility in some applications. When come to the applications, it's a high power laser compared to helium neon laser. So industrial purpose we can use for cutting, welding, drilling, and in medical applications also we can use by tuning it. Tuning the power we can use in laser surgeries, therapies, and photodynamic therapies we can use, and dental procedures also we can use this Nd:YAG laser, and military applications, scientific research, environmental monitoring, display technologies. So when come to the applications, we have a vast number of the applications are there. So that's all for today's session, and I hope you enjoyed this class, and we will meet in the next class. Have a great day. Signing off, Dr. Shivnagari.